Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Sammy said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly, and they will respond individually to you. Today, we welcome Robert Bellassai, Senior Staff Engineer of Underwriters Laboratories, LLC, Melville, New York, USA, who will be presenting his paper on Low Smoke Halogen Free, LSHF. What does it mean? Robert Bellassai is a Senior Staff Engineer, Registered Communications Distribution Designer, RCDD, a distinguished member of technical staff and subject matter expert for UL's local area network performance certification program with 27 years of experience at UL. Robert is responsible for certification testing of telecommunications cabling products. His responsibilities include certification investigations as well as follow-up program standards development for both safety and performance testing, assuring global competency and consistency among UL's cable engineering staff and for his thought leadership. Robert, we welcome you to present at today's IWCS webinar series event.
Thank you, Sammy. I would first like to thank the IWCS team for giving you all the opportunity to present today. And also I'd like to thank the participants for attending this presentation. So as Ed mentioned today, the topic is going to be low smoke halogen free, and what does it mean? So what we will be discussing today, what's all the confusion about, demand drivers, why is LSHF important, what's a halogen and its sources, common materials used in the wire and cable industry, current new industry standards, standards in development, cable marking, value proposition, and we'll have a Q&A session at the end. So what's all the confusion about? Well, in a nutshell, it's halogens, but specifically, it's terminology and definition. As you can see up on the slide, we have some acronyms that are used very commonly in the industry. If you were to perform a Google search and just perform the Google search on low smoke halogen free, and you click images, you would come up with some of these acronyms. So some of them are, low halogen, non-halogen, HFFR, LSZH, very common one, LSF. So what you need to keep in mind is that all of these acronyms are not standards-based. They're really just self-declared or self-certified products that each manufacturer will self-certify and make claims to halogen content and low smoke generation. So the problem, though, exists, and the confusion exists, is that if, let's say, you have three manufacturers, let's say manufacturer A, B, and C, and let's say manufacturer A used terminology HFFR to describe their product, and manufacturer B used LSZH, and manufacturer C used LSF. So each manufacturer is using different terminology, and none of these terminologies are standards-based. So that's what leads to the confusion, at least part of the confusion. The other part of the confusion is the specific test standards and methods that are available today. Some standards do have halogen requirements, but they're embedded in the standards, and some of these requirements are really not very clear. So I'll use one as an example. The first one, the MIL-DTL-24643C standard. So if we look at the requirement, it says all materials shall be halogen-free and have no more than 0.2% halogen content. So the first problem with that is that it doesn't specifically say which halogens you're supposed to test for. And we're going to go into later on in the presentation how many halogens there are. There are 5. But it doesn't specifically say which ones to test. Is it all the halogens? Is it just chlorine, fluorine, and bromine? So it's a little ambiguous. And then if we go on to test description, or would be considered test method, it goes on to say, halogen content of cable jacket or fillers shall be determined by XRF or analytically following an inspection and analysis of the chemical composition of all ingredients used. So there it goes on to exclude the insulation, color concentrates, or any other component other than the cable jacket and the filler. But then it also goes on to say that you can determine halogen content by 2 different ways, either by test using XRF, or don't test it at all and just analyze the chemical analysis of the compound. So now it kind of leaves it open to interpretation, and again, kind of confusing. So what are some of the demand drivers? So specifically, government industrial restrictions around closed spaces such as subways, tunnels, ships, submarines, mines, and those are the typical demand drivers. But over the last few years, hospitals and schools now are looking for low smoke halogen-free products. The PVC fallout, specifically of plasticizers and lead and cadmium, which are heat stabilizers or are also found in color concentrates. Also the green movement, Lead Green Building Initiative and Prop 65, and the precautionary principle, where, well, if the action should be taken if the consequences are uncertain or potentially dangerous. So if it's bad in one area, well, let's ban it everywhere else. So that also is one of the demand drivers. So why is LSHF important? So what the concern is, when halogenated materials are burned, they combust, and the combustion products cause corrosivity and toxicity. So specifically, when speaking about toxicity, the toxicity would be for humans in a building or in a space. And specifically, when we're talking about corrosivity, we're talking about the corrosive nature of the smoke on the electronics that power all of our systems today. So as an example, if you have an emergency call center and you happen to have, let's say, a small but smoky fire in one section of the call center. So those cables and those switches would be damaged, they'd be replaced, and you're assuming that, well, once you turn on the system, everything will work fine, which it will initially. But what's found is that over time, 6, 7 months, maybe a year, other switches and other electronics will fail in the emergency call center. And it's not necessarily because they were damaged initially during the initial fire, but it's because they were damaged by the smoke that was created and filtered into the electronics that were not initially changed. This was actually the case back in the 70s with an AT&T central office fire in Manhattan. That exact scenario happened, where there was a small but smoky fire, and the switches were replaced, but then about 9 months later, they started having failures, and they didn't realize why until they performed an investigation to determine that it was the smoke that was generated from that fire 9 months ago that had corroded away some of the electronics and causing the switching failures. So those are the 2 concerns. So corrosivity and toxicity. So what's a halogen? So if you remember from your high school days, the periodic table of elements, if we go down to the 17th column and it's the orange column, the last one before the one before the last column in the periodic table of elements along the right. You'll see 5 elements: in fluorine, chlorine, and bromine, and iodine and astatine. The first 3 are most common in wiring cable: fluorine, chlorine, and bromine. Astatine and iodine are not as common. However, they may be common in certain applications for certain compounds. But the majority of the compounds do only contain fluorine, chlorine, and bromine. So primary sources of halogen, specifically in polymetric materials, it's the base resin. So I gave some examples there: PVC, FEP, CPE, polyethylene. That's the base resin. The additives, and specifically flame retardants and mineral fillers, and specifically with flame retardants, it's brominated and chlorinated compounds, and specifically with mineral fillers, it's usually fluorine and silica glass, and also color concentrates. Color concentrates we found are a very big source of halogens. So some common flame retardants used in non-hal applications, specifically metal hydroxides, ATH, and magnesium hydroxide, phosphorus or melamine-based, and others. So common resins used in non-hal applications, specifically they revolve around polyolefins. Now polyolefin is a kind of a general term. If you want to break that down into more specifics, it would be considered polyethylene or polypropylene. And there are some others, but not as popular in the wiring cable industry, such as polyesters, polyimides, polystyrenes, and polystyrene and polycarbonate, not really used in wiring cable, but they are also non-hal resins for non-hal applications. The UL certified HF and LSHF wiring cable program was instituted about 1.5 years ago, and the program is based on IEC standards. So as we mentioned earlier, some of the confusion revolved around standards and specifically the test methods and the requirements. But it was about 2 years ago now that the IEC developed a standard specifically for the wiring cable industry that specifically called out 3 important things. They called out the halogen content requirements and test methods. They called out the low smoke requirements and test methods. But most importantly, they actually call out a surface marking, which is LSHF, which is now a standards-based mark. And this IEC standard is 62821, and it's a series, so it's -1, -2, and -3. So finally, the industry now has a wiring cable standard that incorporates all of those very important elements: halogen content requirements, smoke requirements, and again, most importantly, is the actual marking. So the specific cable designation, as we discussed, is low smoke halogen free. So let's just break that up into parts. So there's an LS part and there's an HF part. Now the LS part, I just want to make sure there's no confusion in that LS does not mean limited smoke. There are some standards, both CSA and UL standards, that call out cables as LS. If it's LS by itself, it means limited smoke, not low smoke, as it does when you have the combined acronym of low smoke halogen free. And the second part of it is halogen free. So the LS part that specifically pertains to the complete cable construction. So that complete cable construction is burned, and that's what we're measuring the smoke from. The specific halogen or HF part of the mark is for each combustible component in the cable. So that includes insulation, that includes color concentrates, that includes fillers, tapes, wraps, anything, jacket, anything that will burn in the cable, anything that can combust, will have to be HF recognized, so halogen free recognized in accordance with the IEC standards. which is what we adopted in our program. And our program, specifically those requirements are called out in UL 2885. But they are based on the IEC 62821 series of standards, as we mentioned in the previous slide. So the low smoke part. So what the IEC standard says to do, and specifically it's the 62821-3 series, is it says to burn the cable to the IEC 61034-2 smoke density chamber. And there's an illustration on the slide. And basically what it does is you mount the cable in a fixture, you ignite the cable using an accelerant, you exit the chamber will fill with smoke, and the test lasts for about 40 minutes. In that time, you're measuring the smoke density or the optical obscurity of the smoke, and the minimum requirement is 60%. So if you have too much smoke in the chamber, you will not get at least 60% of the light transmitting through the smoke, so that would be considered a failure. The next part of the marking is the HF part. So HF, halogen-free, and specifically, there are a lot of ways to measure halogen content. Some of them we mentioned earlier, XRF, but there are some others, combustion ion chromatography, Fieldstein method, or sodium fusion testing method. And we highlight the sodium fusion testing method in red is because in the IEC standard, specifically 62821-1 and -2, it lists a 4-step process to assess the halogen content of the material. It's kind of a lengthy process, but it's summarized there on the slide. It goes through 4 stages, starting with stage 0, which is sodium fusion. And the sodium fusion test is a quick test, and what it does is it's kind of a sledgehammer approach. So if, when performing stage 0, the results are negative, meaning that there are no halogens detected in the solution once the sodium fusion is actually completed, then you do not move on to the rest of the stages. And the material is considered halogen-free. And the reason why that happens is because when we, in this process, stage 0 process, when we add sodium paste into the material that's being tested, and then we add silver nitrate to the solution, if the solution becomes cloudy, then that means there's presence of chlorine or bromine. Doesn't exactly tell you how much, but it just tells you that it's there. But it's very positive. I mean, it's either there or it's either cloudy or not. So it's a very good test. It's a very, it's not a very new test, sodium fusion, but it's a very old test actually. But it actually has a very good detection limit, roughly 1,500 parts per million. So, but now let's say the results are positive for sodium fusion, which that's bad. That means that the solution turned cloudy in some way, even in the slightest way, by visual means. Then you go on to stage 1, which is performing a pH and conductivity measurement. And then depending on the results of that stage, you might have to go on to stage 2, which is specifically bromine and chlorine measurement in terms of HCl. And depending on the results of that stage, you might have to go to stage 3, which is a fluorine content stage. And the fluorine content measurement is using, we use XRF, but we can also use CIC. CIC is actually more accurate. But keep in mind that the 4-step process does not mean you have to go through every step, every stage in the process. You might, for one material, start at stage 0 and stop at stage 0. You might get another material, start at stage 0, and you might have to go all the way to stage 3, or maybe even 2 or 1. It all depends on the results that you obtain for that particular stage that you're testing for. So cable marking. So currently, any of our UL listed or recognized requirements do not change. So this option is available for any UL listed or recognized cable. So any of the current requirements that are in any UL standard, whether it be a listed or recognized cable, that does not change. This optional marking is an add-on to an existing type designation. So as an example, we have there an example shown in the slide as best cable company, your E number, the UL mark, and in this particular case, we have a CMR-LSHF. So if it was some other NEC type, like as an example for TC, tray cable, it would be TC LSHF, or we even have AWM styles that are HF and LSHF. So just keep in mind, you might also see, probably to a lesser extent, but you might also see the surface marking of HF. HF just means that the compounds have been evaluated for their halogen content. It does not mean that the cable is low smoke. So the complete and most effective mark is low smoke halogen free, LSHF. So there are some new standards that are being developed. Some of them are listed here on the slide. IEC 60754-3. At the moment, the IEC has a -1 and -2. -3 is being developed and should be published sometime this year. And specifically, it talks about a test method for analyzing combustion gases, but specifically using the CIC method, combustion ion chromatography method. There are also some other standards listed there, and they're including I'll go down to the third one, 63031, and that standard is a low halogen standard. So it's not halogen free, it's low halogen. So once these standards are published, we will have specific programs revolving around them, but it just gives you a snapshot of all the work that's going on just in the IEC committee for low smoke halogen free or halogen free or low halogen. It's becoming a very hot topic, and the standards bodies are realizing that, and they're starting to develop a lot more standards that are very clear and very specific as to their application and their use. So what is the value of an LSHF, especially a UL LSHF cable? So specifically, if a manufacturer does have the opportunity to comply with all the results of LSHF, they're listed on our ul.com site. It's very easy for anyone to look up. So if our customer's customer happens to need a low smoke halogen free cable, they can go on ul.com and they could find out exactly who to call to get it. So it's very easy to find out who's there. More importantly, though, it clears up the confusion and it avoids self-declaration and self-certification of these products. I mean, that's really the main value proposition is the confusion. We finally, our wiring cable industry, finally has a standard that is specifically for wiring cable and lists all of the requirements that someone's going to need to be able to evaluate this product for its smoke and halogen content. Our program is based on globally recognized test standards and test methods, specifically the IEC 62821 series. We have a follow-up program similar to any other UL listed or recognized product. These involve unannounced factory visits and market surveys. We're the first and only NERDL to offer such program. And specifically, HF and LSHF products extend lead green building points to end users. So if you, let's say, are manufacturing, or let's say you're the owner and you want your building to be a green building, there are different levels, gold, silver, and so on. And it all is based on the number of points. The higher points you have for products that are in this building that are considered green, the higher your ultimate certification would be for this building. And having HF and LSHF UL listed and recognized products in that building will extend LEED green building points. And the LEED green building certification is administered by the U.S. Green Building Council. Also, it avoids the International Living Future Institute Red List. The International Living Future Institute is actually very similar to the U.S. Green Building Council in that it lists a bunch of compounds that are not good, so to speak, and things like mercury, lead, chlorine, fluorine, bromine, and so on, and many, many others. So again, having a product that's HF and LSHF would avoid you from getting onto the red list. And the other one, and I mentioned it earlier, is Prop 65. Prop 65, specifically, or Proposition 65, specifically is a regulation in the state of California. And again, it's similar to the red list, where it lists a bunch of elements or compounds that are not good and are avoided, or you want to avoid due to their carcinogenic or deadly effect on the human body. And it also, HF and LSHF products also avoid you from having problems with Prop 65. So that concludes our presentation. I'd like to thank everyone, and we are now going to open the session to questions and answers.
Yes, and thank you, Robert. At this time, we will ask as many questions from the attendees as time permits. I'm going to start with this first question. How will UL's listing/marking program for halogen-free cables impact codes and standards, such as Platinum Network communications cables that need halogenated materials to pass the fire test requirements?
Well, that's a very good question, and it's a question that we get a lot. At the moment, there really are no plenum-rated compounds that are low smoke halogen free. So, but our industry, specifically compound manufacturers, such as Poly One, Technor Apex, Mexichem, and many, many others, are all they're all feverishly trying to work on compounds that will pass the NFPA 262 plenum test and also be low smoke halogen free. But at the moment, there aren't any. The National Electrical Code at the moment does not have requirements for LSHF, but there is some work in the process of being done to include low smoke halogen free requirements in the 2020 code. I hope that answers the question.
Okay, thank you. Next question is, I have seen various global standards that only call out chlorine and bromine as the relevant halogens to be screened. Is this simply to deselect PVC? Why isn't fluorine also considered a halogen in these standards?
Well, that's another very good question. And this, again, goes back to the confusion of standards and the requirements in each standard. Again, if you're looking at it strictly from a chemistry standpoint, there are 5 halogens, and we described what they were: chlorine, bromine, fluorine, acetine, and iodine. And again, in the wire and cable industry, it's really chlorine, fluorine, and bromine. Why certain requirements are written the way they're written, that's a good question, and it's not something I think I can answer. But just keep in mind that the IEC standards that UL uses for our program call out specific requirements for chlorine, fluorine, and bromine. Those 3 elements. Again, iodine and acetine are really not really used in wiring cable, so that's why those elements are not verified for the assessment of halogen content in materials.
Okay. Next, with the rapid ignition and spread of flame associated with halogen-free materials relative to halogenated compounds, isn't this a more critical fire hazard criteria than corrosivity or toxicity?
Well, they're both important. Remember that the low smoke halogen-free mark is an add-on. The current requirements for any UL-listed or recognized cable do not change. So this is an add-on to any product. So it makes a product better. It's not what's more important and what's not more important. It makes the product better. You know, a CMP or any plenum rated product that also has the ability to be LSHF would quite frankly be the holy grail. And as I mentioned, the compounders are feverishly trying to develop compounds that will pass the plenum test and also be low smoke halogen free. But keep in mind that none of the requirements change that currently exist for any UL listed or recognized product. This is an additional certification. So if, as an example, let's look for, let's say, a riser product, CMR cable goes through the UL 1666 flame test. And that's very important, and that constitutes flame spread, and you don't want the cable in a building to spread from one location to another. So you want to mitigate that, and that's what that test tries to determine. But in addition to that, now if you had a cable that was that plus LSHF, now you're covering flame propagation and corrosivity and toxicity. So now you're covering it all.
Okay. I just had one come in that said, can you repeat your comment regarding the NEC code to include restrictions on halogens?
Yeah, there's some work going on that in the NEC that will add this as an option. Right now, the NEC has LS, limited smoke, and there's some work going on to try and add the LSHF as another option. So the LS option still exists. The limited smoke option still exists. But then you would have an HF option and an LSHF option. And all of this would all depend on the application and ultimately what your authority having jurisdiction requires for that application.
Okay, Robert. So I'm going to take this. I think you might have just covered it, but I'm going to ask a question by another. If in LSZH, the LS means low smoke, while LS by itself represents limited smoke, what is the difference between low smoke and limited smoke designation?
Yeah, that's a great question. So limited smoke is what we currently have now that are cables marked -LS. And limited smoke is tested to UL 1685, specifically either the vertical tray flame exposure or the FT4 flame exposure with smoke measurements. So the LSHF, low smoke halogen-free products, the LS in that acronym, just takes into account the smoke, but it's a different test method. So the test method is what's used in the 61034-2, and it's the illustration that I had on my slide. It's that cube test. So it's a different test method for low smoke in the low smoke halogen free versus the LS, the limited smoke, which is currently an option, and that test standard is UL 1685.
Okay. And by the way, Robert, please feel free to refer to a slide if you feel you want to. This next question came as a two-part from an attendee. What results from stage 2 testing would cause moving to stage 3 testing, such as presence or absence of chlorine or bromine? And then as a follow-up, from a previous slide, it indicates an LSEH product could be very corrosive when burned. They just do not contain halogens, could also be a higher CO producer. Is this really safer with this label?
Okay, I'll take the first question. I went back to that slide with the 4-step process. So if the stage 0 happens to be positive, meaning that there is some presence of chlorine or bromine, you go on to stage 1. Stage 1 is specifically pH and conductivity. And the pH needs to be at least greater than 4.3, and the conductivity needs to be less than 2.5. So if you're within those parameters, then you would stop at stage 1, and that would be considered a pass, and there would be no further testing to stages 2 and 3. Ed, can you repeat the second part of the question? I'm sorry.
Yes. Let's see, the second part, it said, the attendee said from a previous slide, and unfortunately I don't know what that might be, but it said from a previous slide, it indicates a LSEH product could be very corrosive when burned. They just do not contain halogens. Could also be a high CO producer. Is this really safer with this label?
Well, again, this boils down to the confusion that's in the industry. LSZH is a homegrown, marketing developed term that, by definition, it means low smoke, zero halogen. So if a manufacturer uses that terminology, then they're self-certifying their cables in some way, which, it could be different than manufacturer B or C, but they're certifying their product in some way to make a claim to the product having zero halogens, which, I don't know, nothing is ever really zero, and for it to being low smoke. So, again, low smoke, zero halogen is essentially the same cable as the LSHF cable, but the low smoke, zero halogen cable that's labeled as such and it's marketed as such is unknown as to exactly what standard was used to test, what requirements were used, and if known by that specific cable manufacturer, it could be different from manufacturer to manufacturer. If you have 3 cables manufacturers that use the terminology LSEH, each one of them might be testing using a different test method, using different test requirements for the amount of halogen content, specifically fluorine, chlorine, and bromine, and specifically what part of the cable they might be testing. I've seen some claims of manufacturers saying, well, my cable is LSEH because my jacket does not contain halogens. Well, but what about the rest of the cable? That's great that the jacket, doesn't contain any halogens, but what about the insulation? What about the fillers? What about the color concentrates, the tapes, the wraps, the fillers, so on and so forth? So I hope that answers the question.
Okay. Me too. And I'll just again remind anybody listening that, of the offline contact can happen as explained. Next question. The why is LSFH important slide, the why is LSFH important slide doesn't take into account important attributes of fluoropolymers or low smoke PVC rather than the generation of carbon monoxide, HCl, etc. Isn't minimizing ignitability, flame shred, and smoke generation more important?
Well, again, I think we kind of answered a similar question. Remember, LSHF is an additional optional marking that's added to a already listed product. So if the listed product is, let's say, and let's say it's not a plenum cable at this point because there are no compounds that are low smoke halogen free that could pass the NFPA 262 test. But let's say it's a CMR cable. So you have the advantages of flame propagation or the mitigation of flame propagation that a CMR listed cable gives you, but now you're adding on the smoke and the corrosivity and toxicity benefits of that cable. So you have now like 3 benefits. You have the flame propagation benefit, you have the corrosivity benefit, and you have the toxicity benefit. What's more important? That's going to be dictated by local codes and standards. But if you need something that is low smoke halogen free and is also does not propagate flame, then you need to have a cable that's UL listed for whatever this specific type is, in addition to the cable being certified as low smoke halogen free through the UL program.
Okay, thank you. Next, does the listing include tests for material stress whitening and aging, cracking of the jacket over time?
Yeah, that's another great question. Again, any mechanical tests or electrical tests that are currently required do not change. So if there are, like as an example, we perform tensile and elongation measurements for insulation and jacket on listed cable, and we do that test for every UL listed and recognized cable, and every UL standard has that requirement. And the reason why we have that requirement is because we want to make sure that the jacket over time doesn't degrade and fall off and potentially cause a hazard. So that requirement has not changed. That requirement for whatever the specific standard is still remains. And if there are any other requirements, they also still remain. Again, the LSHF is an optional mark that's tacked on to an already listed or recognized product in accordance with the applicable standard for its listing or recognition.
Okay, thank you. Next, antimony oxide is currently used in conjunction with bromine and FR. There were many discussions about ATO, but are you aware that this component will be added to the list of non-RoHS?
Yes, I was aware of that, yes.
Okay. All right, simple enough. Thank you. Is it now true that each individual component, no matter how small a percentage of halogen total material volume, invalidate a LSHF listing, even if it is less than the accepted value in average? Well,
the requirement, as any requirement, it's never an absolute. So in the case of a low smoke halogen-free cable, the material may contain halogens, but they are below what is required in the standard, and in some cases are so low that they can't be measured. So a low smoke halogen-free doesn't mean that there is an absolute 0% of halogens in that particular compound, and in total in that particular cable. What it means is that it conforms with the IC standards and has conformed with the detection limits for the IC standards, which is roughly in terms of parts per million between 1,000 and 1,500.
Okay. Next, and Robert, what I'm going to do, I've got about roughly 4 or 5 questions. I'm going to try to get through as many as I can by our stop time here of about a minute or two. Okay. So let's try to cover these best we can, and if not, we'll figure out how to share these out. Next question. So the correct marking for a cable with LSHF features should be TC-LSHF, or can the LSHF mixed with the rest of the marking, as shown on the example?
Yeah, so let me see if I could go back to the marking slide here. All of the marking that is required for a cable needs to still be there per the applicable standard. In this case, it's the TC standard, which is what you're asking about. So you would have to have the company name and or the file number, the UL mark, and the temperature rating, the conductor size. All of those requirements are still valid and do not change and are in accordance with the TC standard. But you would then tack on, if the cable complied with the smoke and halogen requirements, the LSHF immediately after the TC designation. So it would be, as the example shown here on the slide, we have CMR LSHF. It would be, as an example, TC-LSHF. Correct.
Okay. Robert, I'm going to ask you one more question and then remind attendees that if for whatever reason we didn't get to your question because we're running out of time, your question can be addressed to the presenter. Last question, are UL 2885 and IEC 62821-3 harmonized?
Great question. So our program is the UL 2885 standard is based on the IEC 62821-1, 2, and 3 standard. Let me rephrase that. UL 2885 is actually related specifically to the -1 and -2 standard. So what we did was we extracted the halogen-free requirements from UL 2885. And regarding 62821-3, we sent out an announcement bulletin to the industry stating that cables that are to be marked LSHF need to comply with UL 2885, which is the IEC 62821-1 and 2 requirements, in addition to 62821-3, which includes the low smoke requirements and the marking requirements of LSHF.
Okay, thank you. We need to conclude Q&A for now. I'd like to thank you, Robert, for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Robert after today's event. Each of these IWCS webinar series presentations events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, March 17th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so they can join in and register as well. For over 65 years, the IWCS International Cable and Connectivity Symposium has been a recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, October 8th through Wednesday, October 11th, 2017 at the Gaylord Palms in Orlando, Florida, USA. In addition, the inaugural regional UL and IWCS China 2017 Cable and Connectivity Symposium will take place on Tuesday, April 25th through Thursday, April 27th, 2017 at the Marriott City Center in Shanghai, China. Please visit our website at iwcs.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.